This is a lesson on Venn diagrams and sets, and it covers chapter 20.1 from the GCSE textbook. So there's a few things that we want to cover in today's lesson. A lot of the work that we'll be doing to do with Venn diagrams relies on you knowing and understanding the terminology that's used to do with these. So we're going to cover all of the sort of terminology and notation that you need to know. We're going to put some information that's given to us into a Venn diagram, and then also we're going to make sure that we can identify certain regions in a Venn diagram by shading them. Okay, so here's a quick little starter. You would have come across Venn diagrams before, I'm sure. So let's just sort of see how much you know already about Venn diagrams. So this was quite an interesting picture that I found. And it's a way that a restaurant had actually displayed their menu for their sort of options for their breakfast burgers. And they displayed the pricing for them all using a Venn diagram. So it's quite an interesting idea, this. Let's see whether you understand actually what it all means. So if we have a look at let's choose one particular section on here. So say if let's use red so you can see it. So say if I put a little star in this section here. Now let's think about what this section represents. This whole circle up at the top here, this whole circle represents a burger that's got egg in it. So anything within that circle has got an egg in it. This circle at the side here, that represents having bacon in your burger, in your roll. And then this section here represents having sausage. So if we have a look at the section that I've put a star in, this section here. Now the price they've quoted is £3.50. What does that £3.50 cover? Well, it covers a breakfast bap that has both egg and bacon in it, because it's in both the egg and bacon circles, but it's not in the sausage circle, so it's just egg and bacon but without sausage, and that would cost you £3.50. Okay, let's choose one of the other ones then. So if I was to choose, say, something in this section here, so let's shade just that section there. Now we see the pricing is £3. Now within this section here, it's in the sausage circle, okay, but it isn't in the overlap with the egg and it isn't in the overlap with the bacon. So that just tells you that a sausage, breakfast bat with just sausage would cost you £3. Okay, the final one then, let's have a look at this section right in the middle here. If I have a look at things that are in here, now if you look at which circles they're in the egg circle and the bacon circle and the sausage circle. So that would be a breakfast bat with all three parts in it, and that would cost you £4. Right, there's one bit that we've not really looked at, which is this part here. Now this is completely separate from the Venn diagram, it's outside all of those. And that says mushroom in it. So what that says is that we can have that with any of those just for an extra 50p. So I thought that was quite a nice, neat use of a Venn diagram and talking about things that you probably know and love to eat yourselves. Okay, let's crack on with the lesson then. Right, notation. So make sure you've got your exercise books ready. Make sure you write the title. Okay, which is Venn diagrams and sets, and let's make some notes. So a set is a collection of objects, okay, so a collection of things, and we can define a set either as a list of individual items or we can define it using a rule. So let's have a look at an example of each of those. We typically use a capital letter for a set, or we might use a word that's associated with it. So notice the use of these curly brackets to hold together all of the definition of the things that are in the set, or the rule that makes the set. We always draw curly brackets around it. So set A, I've defined just as the objects 1, 2, 3. Or if you have a look at set B here, that's what we call a rule. So that's where a set is defined as a rule. So how we read this is we say the set of X. Now this means such that. So the set of X such that x is bigger than 2, where x is an integer. So if I think about what elements would be in that set, I wouldn't include 2 because there's no equals to, so it would be the elements 3, 4, 5, and actually that is an infinite set, okay, because it's got an infinite number of numbers that are integers and bigger than 2. Okay, so make sure you understand you can list things and you can also define them as a rule. Okay, so if you ever see in a question it talks about elements, then an element is each of the object that's within the set. Okay, element or member, those two words. Now here's another bit of notation here, this symbol here. Okay, so this that looks like that is a bit like a curly E, okay, and you read that as is a member of or is an element of. So you can see that what I've written down here, I've said 1 is a member of A, because here it is. Typically when you have a symbol, if you have a line through it, that means is not A. Okay, so this, you would read this as 2 is not a member of A, and you can see that 2 isn't a member of A. So make sure you remember that, okay, because that sometimes comes up in questions. It's is a member of, or if it's got a line through it, is not a member of. Okay, the number of elements in a set is given by n brackets A. So in our particular example up there, I would have done another example here. If D is the elements 2, 4, 6, 8, then ND equals 4. Again, that sometimes comes up in questions. Okay, there's a special set called the empty set. It's not a very exciting set, but it's a set with nothing in it. 2 bits of notation you can use to define it. You can have your curly brackets with nothing in, or there's this, which is a circle with a line through it, okay, and that is called the empty set. So it's a set with no members in it. Okay, final little bit of notation. The universal set, that's like a curly letter E there. The universal set is all of the elements that are being discussed in a particular problem. So you'll see when we draw some Venn diagrams in a moment, we usually, as well as drawing the circles that make the different sets, we also draw a box around it, because that box contains all of the elements that are being discussed in our problem. Okay, so the universal set, that curly E, that means all of the things I'm interested in. Let's have a look at some Venn diagrams then and what the regions on them represent. Okay, again, here's some more notation for you. So I have 2 sets A and B. If I talk about the intersection of A and B, that is where they cross over each other. Okay, so let's have a look at the diagram that would represent that. So notice Venn diagram, I've got my circle A, I've got my circle B, I've got them overlapping. Notice my use of this. I've drawn a box around it and I've put next to the box E, because that is my universal set. So anything in that box is the things I'm being discussing for that particular problem. So the bit I've got shaded here, so make sure you've drawn this down in your notes. Pause the video if I'm going a bit quick for you. The shaded bit here is the intersection of A and B. It's where they overlap, and that is where you have elements that are in both A and B. And this symbol here means the intersection, so that means in both of them. Right, we've got another symbol which means the union. Okay, now a union, how you can remember this is the union symbol looks like a big U. So you can remember U is union. Okay, the upside down one is intersection. Now the union of A and B is joining A and B together. So it's all of the elements that are in either A or B, or indeed both of them. Okay, and that's the union of A and B. So it's joining the sets together. Again, this terminology, this notation, you need to remember because it comes up in questions. So union, a big U, intersection, upside down one. Okay. The complement of a set, you might not have come across that terminology before. The complement of a set is the set of elements that are not in A. So let's have a look at a Venn diagram that represents that. Okay, the notation for the complement is A with a little dash like that. So you may see that coming up in questions. So make sure that you remember A dash is how I would read that. A dash is the complement of A. And what that is all of the elements that are not in A. So you can see in my diagram here, I've shaded absolutely everything. Okay, which is what you're going to write in your notes. Absolutely everything apart from the circle A. Okay, and that's called the complement. So make sure you've got all those written down. If you need a bit more time, then just press pause. Okay, right, let's crack on with our first example. So again, pause the video, copy down example as the title and copy down the question exactly as it appears there. Okay, so we've got a class of 23 students. We've got 15 like coffee, 13 like tea, and 4 don't like either. Draw a Venn diagram to represent this and use our Venn diagram to find out how many like tea only, coffee only, or both drinks. So our Venn diagram, we're going to have a big box that goes round everything. This is the universal set, everything within that box, and that contains 23 students. So we should have 23 students within this box. Right, we need a circle for coffee. So I'm going to draw a circle and I'm going to write a C next to it to say that's for coffee. We need a circle for tea. Okay. And I've intersected them because there's probably going to be some that like both because it's mentioned in the question there, how many like both. Right, before I start filling it in then, okay, I need to have a think about how many are going to be in that intersection. Okay. Right, if I look at the people that are mentioned in my question, in total, they've mentioned 15 like coffee, they've mentioned 13 like tea, and they mentioned 4 don't like either. Now, if I add all of those together, so 15 plus 13 plus 4, that gives me 32. Now, I can make use of that to work out how many like both of them. The way I can make use of it is my class is 23 students. When I add up the things that they've mentioned, I get 32. So what that tells me is some of the students have been counted twice, and those students are the ones that are in the intersection. Okay, because they're in the intersection, they've been counted twice in effect because they like coffee, so they're in that 15. They like tea, they're in that 13 as well. So let's work out how many are in the intersection. So like both is going to be the total of what's added up, which is 32, take away 23, so that gives me 9. So I can put that 9 there, I can put in my intersection. Okay, right, now I can fill in the rest of the diagram. Okay, right. My question says 15 like coffee. So in total, in that circle for C, there needs to be a total of 15. There's 9 in the intersection. So what that tells me is there must be 6 in here. Okay, because that 6 comes from doing 15 take away 9. So in total in C, I've got 15. Okay, similarly for the T, 13 like T, I've already got 9 in the intersection, So that tells me that I must have 4 that like just T. Reason being, that is going to be 13. Take away the 9 that I've already counted in my intersection. Where do I put these 4 students? Have a think about it. 4 of them don't like either. So they can't be in the coffee circle, they can't be in the tea circle. So the 4 that don't like either, these ones here, they go outside the circles, but inside the box. So that's why we have the box around here. So we make sure that the whole box should add up to 23. Let's just do a quick double check. 6 plus 9 plus 4 plus 4 gives me 23, so I'm correct. Okay, I can now use it to answer my question. How many like tea only? Well, that's going to be within the tea circle, but not in the intersection because they only need to like tea. So that's going to be 4. Okay. How many like coffee only? Again, that is going to be in my coffee circle, so in my C circle, but not in the intersection because I want them to only like coffee. So that's going to be 6. How many like both drinks? That was what we worked out first. It's important you work that out first, okay, before you start putting things in, because we need to know, make sure we don't double count those people. How many like both? And that's 9. Okay, so if you didn't quite understand that, you can always replay the video, but do make sure you've got that written down as a good worked example for your notes. Hopefully you've understood what we've done here. We've added up the ones that they've mentioned. We've noticed that there were too many. They totaled 32. So that tells us that we've counted 9 of them twice. So those 9 must go in my intersection. Okay, right, let's look at a second example. So again, make sure you just pause the video for a minute and write down that. Right, this is one where we've got more things sort of just described actually as sets. So notice we've got the curly brackets. This here, it's a bit of an extra curly one, but this is E, which is my universal set. So this is all of the numbers that I am considering in this question. Okay. So set A is given by a rule, the factors of 12. Set B is given by this list of numbers here, 2, 3, 5, 6, 11. And I've got to find some sets here. Now, what might be useful first is to actually list the elements that are in A. So factors, remember, what's a good way to define the factors is think about the factor pairs. Okay, so factors of 12, 1 and 12, because 1 times 12 is 12, 2 and 6, 2 times 6 is 12, and 3 and 4, 3 times 4 is 12. So I've opened my curly bracket. Do make sure you list them in a curly bracket. And just to make my life a little bit easier, I'm going to list them in order. Okay, but notice how we worked out the factors of 12 by doing them as factor pairs. So 1 times 12, 2 times 6, 3 times 4. Okay, I'm just going to write out B underneath because I'm going to have a look at these when I do my question. That's 2, 3, 5, 6, 11. Okay. Now the question doesn't ask me to draw a Venn diagram. I can if I want to help me work out the question here, or you can do it without. If the question that doesn't ask you to do a Venn diagram, then you don't have to if you can do it without. Do you remember what that notation meant? It's not a U, it's the other one. So that is the intersection. Remember what intersection meant? That was things that are in both A and B. I've got the 2 lists written up there. So pick out the things that are in both. 2 is in both, 3 is in both, and 6 is in both. Close my bracket. Okay, the second one. So you can see how you need to know what this notation means. That is your big U. Remember what your big U means, union. and that means joining them together. Now, here's a really important thing to note. We need to join together those two sets, but if there's something that is in both of them, we only write them down once. Okay, so 1 is in both of them. I'm going to keep them in order. 2 is in both, but I only write it down once. Okay, so 1 is just in A, sorry. 2 is in both. I don't write 2 2s, I just write 1. 3 is in both. 4 is in A. 5 is in B. 6 is in B. 11 is in B. And 12 is in A. Okay, so you only write the elements once. You don't repeat them if they're in both of the sets. That's an important thing for you to remember. Okay, let's have a look at what this means. A, U, B, dash. Remember what the dash meant? That meant the complement, or it means things that aren't in the thing that's in the bracket. So in words, this would be the elements that aren't in A union B. Here's my A union B. Now I need to look at what my universal set is. My universal set is all of the integers 1 to 12. So have a look at A union B and decide which integers from 1 to 12 are not in there. Well, 1 is, 2 is, 3 is, 4 is, 5 is, 6 is, well, 7 isn't, 8 isn't, 9 isn't, and 10 isn't. So that would be my A union B dash. Now, the question didn't ask me to, but I'm just going to draw a quick Venn diagram, because sometimes if you're struggling a little bit, that can help you to solve your problem. And the question may ask you to draw a Venn diagram. Okay. So what my Venn diagram would look like, the intersection here would have 2, 3, and 6 in, and I just list them like that. A would have the elements of A that aren't in there, so that would be a 1, that would be a 4, and that would be a 12, so that would be an A. B, again, would have the things that are in B but not already mentioned in the intersection, so that's going to have 5, and that's going to have 11 in it. Okay, and then what's left? Well, that's the complement of A union B, so that's going to be the rest of the numbers 1 to 12 I would put around the outside. So if you were asked to draw a Venn diagram for that one, do make sure, okay, that you understand where that's coming from. Okay, right, we're going to have a look at some more interesting regions going on here. So what I've got here is this diagram here. This just basically shows you what we're considering. So A is my circle on the left, B is my circle on the right. We've got an intersection and we've got a square around it, and that's my universal set. So as well as listing individual elements, we can also work out probabilities, okay, to do with elements that are in a set. So all of these things that are mentioned here, in this bit here, all of these are represented by one of the diagrams around the edge. Okay, and what it is whatever things, elements are in the shaded region, in the dark blue shaded region, would give you the probability of A. Okay, so remember, A is your left circle, B is your right circle. So you have a look at the diagrams all the way around the edge. Which one of them has just got A shaded in? That's going to be that one. Okay, so what you want to do in your notes is you want to draw a quick little diagram there, shade it in, and right next to it, probability of A. Let's do the easy ones first, okay, and then we'll look at the slightly more complicated. Probability of B then. So what we're looking for is the diagram where just the B circle is shaded in. So that is going to be that one. Remember, A is on the left, B is on the right. Okay, let's pick some of the other ones we know. Do you remember what that notation meant? The bit in the middle is a big U, so that means A union B. So that is A and B joined together. So pick out the right one. It's that one. Okay, next one then. All right, what we're doing for the next one is we're going to do this one here, A intersect B. Okay, remember it's not the upside down U, so it's intersect. Remember what intersect meant in A, both A and B. So that, whoops, is going to be, sorry, pen's just gone a little bit funny there. That is going to be this one here, so the bit shaded in the middle. Okay, so this is your A intersect B. Okay, right. I'll leave those three at the bottom until the end. This one here, A dash. Remember what A dash meant? It meant the complement of A. So it meant everything that isn't in A. Okay, everything that isn't in A. So you look at the remaining diagrams, that is going to be this one round here, because that's shaded everything that isn't in A. Okay, right, the last three, they're a little bit more complicated, so let's have a look. Let's pick this one. Okay, so this here says I want to union together or join together everything in A and everything that's not in B. So you have a look at the diagrams that are left around the edge, okay, and I've unioned or I've shaded in everything in A and everything not in B. Which one is that? Did you get it right? Whoops, that's going to be that one there. The last two, here you go, I've got the intersection of A dash and B dash. So that is saying which diagram shows me shaded in the things that aren't in A and the things that aren't in B. Okay, things that aren't in A is sort of all around the edge and the B circle. The things that aren't in B, where are they both joined together? That's that one. So this is A dash intersect B dash. Okay, we've got probabilities because we're going to do one of those in a minute. And then the final one, this one, okay, goes right the way up to here. Let's just check that one. So that is the intersection of A and what's not in B. So have a look at what we've got shaded here. A is the whole of that circle, but what we've got to do is see where that intersects with things not in B. So it's going to be all of that, but not the middle bit because the middle bit is in B. Okay, so if you need to just pause to write those down, then that might be a good idea. Right, I've got one for you to try now. So what I want you to do is I want you to pause the video now, okay, and I want you to write down the question and I want you to have a go at that. All right, so I want you to have a go by drawing your Venn diagram to help you. I want you to fill in your Venn diagram with the numbers of students in each of the sections. And then once you've done that, you can answer the question. Rather than saying how many students study history and visit Rome, it's saying find the probability. So we'll have a look at how we do the probability in a minute. So you pause it now and you have a go. Okay, we're back now. So how many students should we have in total? 120 in our universal set. So our universal set, which is my box around the edge because that's a bit wobbly, my universal set is 120 students. Right, they've given us some information. They said so many study history, so I'm going to need to have a circle with my ones that study history. I'll call it H. Visiting Rome, so again I need to have a circle, whoops, for those ones visiting Rome, and I've got an intersection there as well. Okay, so let's have a look. They've told us how many study history, how many visiting Rome, and they've told us how many don't study history and aren't visiting Rome, so how many are not doing either. So remember what we did last time? We totaled up how many students they gave us altogether. Okay, and we got 174. So remember, we used that to work out how many of them we had double counted. There should be 120 students, so if I do 174 minus 120, that tells me that I've got 54 are double counted, or I've counted twice. Okay, double counted, sorry, that's my writing. So those 54 go in the middle. Okay, right, back to my question then. 72 study history. I've already got 54 in here, so that tells me that I must have 18 just in here, okay? And I get that by doing 72 minus 54. How many go in the R circle? There's 90 studying, 90 going to Rome altogether. I've already got 54 in that middle bit, so that gives me 36 here. How do I get that? I do 90 minus 54. The final bit I've got to put in is these 12 that aren't doing either. Remember, you pop those around the edge. Just before you move on, double check your figures all add up. 12 plus 18 plus 54 plus 36 should equal 120. Yes, it does. Right, the question is asking for a probability. So I want people that study history and visit Rome. Okay, so I'm looking for the probability of history intersect Rome. So it's the bit in the middle. Now, I know there's 54 there. Okay, so if it asked how many, you would say 54. This is asking for a probability. So it's 54, but it's 54 out of how many students? Back to your question, 120. Okay, and I might just pop that in my calculator and give it as a decimal, 0.45. So the only difference with working out probabilities is that you find out how many there are, okay, and you find out how many there are, and then you put it over how many students there were. Okay, right. One last bit then, conditional probability. Now this, it can be a little bit tricky, all right, and you have to make sure you read the question carefully to identify that they are looking at conditional probability. So put the title conditional probability, copy down the question, pause the video while you do that. Okay, let's read the question here. Now the question here says, what is the probability that the person takes sugar? Now here's the bit that shows its conditional probability, given that. Okay, so those words given that mean that it's conditional probability. Now this is the terminology that they can use in a question. If you put this line here means given that. So this is quite high-end stuff though, so you're unlikely to have this in a question, or it would just be right at the end of a question. So what is the probability that a person takes sugar given that they take milk? Now here's what you do. You look at what the given that thing is. The given that thing is they take milk. So the only people I'm interested in for my probability is the people within this circle here, within my milk circle. I don't care about anybody else. Okay, so when I'm doing my probability, I'm only looking at these 13 people here. So the probability that they take sugar given that they take milk, I'm only looking at the people in the milk circle. So it's out of the 13 that are in the milk circle. Out of those 13, how many take sugar? It's going to be these ones in the middle here. So the answer for that would be 8 out of 13. Okay, so conditional probability, when they say given that, all right, you only look at the people that they say for the given that. You just narrow your view down to that and you work out the probability based on those. Like I said, don't worry too much if that seems a little bit complicated. You will be able to do the majority of the questions without the conditional probability. Okay, right, so here's the work you're going to do. There's a few questions in your book from the textbook, which is exercise 20.1s. You're doing questions 4, 5, 8, 9. Do those in your book. Okay, and then after that, what you're going to do is you're going to do a sheet of Venn diagrams questions. Okay, so you are going to work through those questions. All right. You're going to you're going to need to print the sheet out, you're going to need to print out the sheet, and you're going to need to write your answers on the Venn diagram sheet. Okay, now I'll be posting the answers to that sheet as well, so you can mark your work from the answers. All right, and then what you will be doing for the second lesson of this week is I will set a My Maths on Venn diagrams. Well, there's 2 actually, so you'll be completing those, and those will be what your teachers will have a look at as to how you've got on with this topic. Okay, so anything you're not sure about, just rewind the video, go and have a look back and have a go at those questions, and do email your teachers if you do have any problems with them. Okay, good luck with those.